So now that we know how to represent numbers, integers in binary with 2 bits, base 2, we'll see two different ways to represent negative number, signed number. The first way is to use a signed magnitude representation. So we need to know over how many bits we're working on. So let's say over n bits. And it's very simple. So we'll save the first bit to decode the sign. So we have n bits altogether. We save the first bit here to decode the sign. So that would be 0 if it's positive and 1 if it's negative. 0 positive and 1 negative. So we know the sign of our number. And the n minus 1 bits here will be used to represent the magnitude, that is the absolute value of the number we want to represent. Represent the number from minus 2 to the power of minus 1, because we have now an n minus 1 bits to represent the magnitude, minus 1 because we start from 0, to plus that number. Now let's see an example. So let's say we have n bits to get our number. So we can represent number from minus 2 to the power of 4 minus 1 minus 1 plus 2 plus 2, 4 minus 1 minus 1. So that's minus 2 to the power of 3 minus 1 to 2 to the power of 3 minus 1. So 2 to the power of 3 is 8, so it's minus 8 minus 1. So that's minus 7, because this is between brackets, 2 plus 7. So we have n equals, n is the number we want to encode, so that's minus 3. So we have 4 bits. 4 bits is decode the sign, so that will be 1, and n minus 1 bits will be decode the magnitude, so 1 and 1. And now the other way around, if we have a number in 2 bits that is coded using sign magnitude over 4 bit, we know the first bit here is for the sign, so it's 0, so that's plus, positive, and we know 0, 1, 1 is 3, so that's plus 3. The other way to represent negative numbers is to use the 2's complement notation. So in 2's complement notation, then if the number you want to encode is positive or 0, then you can use a sign magnitude. Well, actually, you can use binary representation. So you know that 0, if the so again, it's over a fixed number of bits, and if the first bit is 0, then you know your number will be positive if the first bit is 0. Then if your number is negative, then to encode the number, you have to calculate 2 to the power of n, or n of where n is number of bits. We have to encode your value minus the absolute value of n. We'll take an example. So we won't code 0 twice as we did using the sign magnitude representation. So we have one more number that we can actually represent. So let's take an example with 4 bits. So we can code number from minus 2 to the power of 3 to 2 to the power of 3 minus 1. So that's minus 8. So you see we have one more value we can encode here, 2 plus 7. So now we want to encode minus 3. So we know it's negative, so it's 2 to the power of 4 minus the absolute value of minus 3. So 2 to the power of 4, 16 minus 3, so that's 13, and the binary representation of 13 in 2's complement over 4-bit is the representation of minus 3. So 1, 1, 0, 1 in 2's complement notation over 4-bit is the representation of minus 3. And it works the other way around as well, because 1, 1, 1, 1 in base 2 is 15. So 16 minus 15 is 1. So minus 1. This number is the representation of the value minus 1 in 2's complement notation over 4 bits. So it seems like it's a bit difficult to actually do the computation, but there is a magic trick to get the 2's complement representation of any number, any base 2 number. So you take your number and you read it from the right to the left, and you copy every one up to the first one included. So here 1, and then you switch. So here you have 0, so it makes 1, and then you switch everything. So 0 and 0, and that's it.